Good morning all. We will be continuing today with equilibrium of concurrent forces, roller numericals. So here we have a two roller numerical wherein find the unknown reactions at all the points of contact. The weights of the rollers which are identical or symmetrical is W equal to 200. If you look at the figure very carefully, the points of contacts being this, and this. So I name them as 1, 2, 3 and 4. Between two rollers, we will always have compressive forces developed, which is indicated by two arrows outwards. And the angle made by the plane here is 30 degrees. So first we have to start with the free body diagram for this. I will be calling this as roller 1 and this becomes roller 2. So we have to draw the free body diagram for individual rollers showing all the forces along with their weights. So starting with the roller 1, this is roller 1 and I will try to draw the roller 2 which will look exactly same to this. I repeat, do not draw the rollers side by side. It will be a little confusing while drawing all the forces over the rollers. See that you draw them as they are but leaving some space in between. So starting with roller 1, this is roller 1, this is roller 2. So starting with roller 1, I have the weights always acting downward, which is 200 Newton. I will show the weight. And then look at the figure. I have point of contact here. That is, I'll have a reaction R1, which acts normal to the plane. I have a reaction R2, which is going to act normal to this plane. I'll have a reaction R4, which is going to be at 90 degrees to this plane. So in this particular given triangle, if this is 30 degrees and this is 90, so this would be 60 degrees. Similarly, this also would be 60 degrees. So I'll have reactions R2 and R4 which are making an angle 60 with the horizontal for these two reactions. So getting back to this roller, if I'm showing, I'll have to show its weight, reaction R2 and reaction R1 along with R3. So we have a weight which is coming downwards, then I have to show R2 which is going like this, R2. We found that R2 is making an angle 60, so this is 60 degrees. I have R1 which is horizontal force. I will show R1 which is a horizontal force, and we have R3 which is compressive, so that means two arrows outwards. It is the compressive force between these two rollers, so R3 will be acting with two arrows outward like this for both R3, two arrows acting outward. And what is the angle between, or angle it is making? This is R3, so this line is parallel to this line, so I know that this plane is making 30 degrees, so this also would be 30 degrees. So I'll have to show the angle here as 30 degrees and this as 30 degrees too. So this completes my roller 1, which has got a weight R3, compressive, R1 and R2. Now coming back to roller 2, it has got its weight R4 and R3. So this is R3 already shown in the figure. Its weight W, that is 200 newtons. And I will have a R4 which makes an angle 60 degree. So we'll show R4 which is making an angle 60 degrees to the plane. So this is the free body diagram for roller 1 and roller 2. Be very careful, do not miss any of the forces. I'll repeat again. For roller 1, we have a horizontal force R1. We have a reaction coming at point of contact 2, that is R2. We have a reaction coming at point 4, that is R4. This is an inclined plane which makes an angle 30 and this is the horizontal. So what we do, considering this triangle, this is 30, this is 90, so this would be 60. So R2 and R4 make an angle 60 with the horizontal, R2, R4. Okay, once your free body diagram for both the rollers is ready, we'll have to pick which roller we will be beginning with. Look at roller 2, it has got 1, 2, 3 unknowns or 3 forces, and roller 1 has got 1, 2, 3 and 4 forces. So we will begin with roller 2 which has three unknown forces. So we will apply directly Lamy's theorem. So by applying Lamy's theorem. So what does Lamy's theorem say? Lamy's theorem is applicable to three forces which are concurrent in nature, and we know their angles. According to Lamy's theorem, we have to take the ratio of the magnitude of one force to the sine of the angle between the other two. So if I'm considering the weight, the angle between the other two forces, that is this angle, that would be 180 minus 60 minus 30 degrees would give me this angle. I have to take the ratio of that. Similarly, R3 divided by sine of the angle this, R4 divided by angle this. So I will just write the condition for that. So by applying Lamy's theorem, I will write first to begin with 200, that is weight. Force is 200 divided by sine of 180 minus 60 minus 30. So look here, 200 divided by sine of, I have to take this angle, that is 180 minus 60 minus 30. This is equal to, okay, the free body diagram is visible now. This is equal to R3 divided by sine of 90 plus 60 and R4 divided by sine of 90 plus 30. So I said R3 divided by sine of 90 plus 60, that is this angle, R4 divided by this angle. So we've written them in terminologies. So this is going to be 200 divided by sine of 180 minus 90, that is sine of 91, equal to R3 divided by sine of 150, that gives me 0.5, and R4 divided by sine of 120, that is 0.866. So we'll come up across such an equation where R3 and R4 are known. What I'll do, I will equate these two equations and get the values for R3 and R4. That is, R3 is going to be 200 into 0.5 divided by 1, and R4 is going to be 200 into 0.866 divided by 1. So the final answers are R3 equal to 100 newtons and R4 is equal to 173.2 newtons when you calculate them. Okay, then we have done with these two. I have to go back to I got to know the value of R3. We found the value of R3 to be 100. So I'll make a note of this. This is becoming 100 newtons now, and R2 and R1 have to be found. So now I will go back to roller 1. I cannot apply Lamy's theorem to roller 1 because I have 1, 2, 3, 4 forces. What we will do is we'll go with the traditional, that is summation f of x equal to 0 and summation f of y equal to 0, that is apply conditions of equilibrium. Okay, so now I will begin with summation f of y equal to 0 first. So all the y forces, I have a 200 and I'll have components of R2 and components of R3. So summation of y equal to 0, I will write minus 200 because it is coming downward, plus R2 because it is at upward, sine of 60 minus R3 sine of 30, that is R2 sine 60 minus R3 sine 30 equal to 0. So this equation reduces to minus 200 plus 0.866 times of R2 minus, I know the value of R3, I will substitute the value of R3 and into sine of 30, that gives me minus 50 equal to 0. So I get the value of R2 as 288.68 newtons because only R2 was unknown. R3 value is known, so we get the value of the unknown R2. Now we will apply summation f of x equal to 0. So I have R1 in summation f of x, I have R3 and I have R2. R2 and R3 values are known, only R1 is unknown. So first let us write the equation for it. So it is R1 positive is going in this direction, R1 minus R3 cos of 30 minus R2 cos of 60 equal to 0. We know the values of R2 and R1. So on substituting, I get the value of R1 to be 230.94 newtons. So these are the 4 unknown reactions which are found. Remember, here we know that we found the value of R2 as 288.6 and R3 is 100. I substitute that in the given equation, I get the unknown value of R1. So in this particular roller, R1, R2, R3, R4 were unknowns, and on solving, we first draw the free body diagram individually, pick the roller which has got least number of reactions, apply Lami's theorem, get the 2 forces, go to the next roller wherein there were 4 forces, apply summation of x and summation f of y equal to 0, which are the conditions of equilibrium, solve for the equations and get the unknowns. So this is an example for 2 roller numericals.